Let's just wait for a couple of minutes. After that, I will start. Okay, let's start. So this is the fourth week, regression analysis, problem solving session. So today, my plan is that I will first discuss about the week three assignment questions, which is based on the multiple linear regression analysis. And maybe at the end, I will talk about the extra sum of square technique because I haven't covered it in the last class. There were no questions also. So, extra sum of squares. This technique is important, particularly to solve one of the questions in the fourth week assignment, which I have seen. And of course, we will go and have a brief discussion on selecting the best regression model, which is generally covered in the week four lectures, NPTEL lectures. So, selecting the best regressor model, we'll talk about that. And corresponding to this, we will solve some practice questions, which will be helpful in solving the week four assignments. Okay, so some practice questions we will have to solve this. Mostly today we will be practicing more questions as compared to more of theories. I will briefly introduce these two so that and also apply these theories in the practical problem, these some practice questions. So this is the overall today's plan. So, so at the starting, I will start with this week 3 assignment. Okay, so I just now switch off the videos, not record of this. Okay, so let me uh, share the screen of the assignment. So these are the week 3 assignments where it is based on multiple linear regression, as I have already told. So the first question of the week 3 assignment is that, just a minute. Yeah. So it says that fit the model y is equal to beta naught plus beta 1 x 1, yeah, beta 1 x 1 plus beta 2 x 2 plus epsilon. So you can see that there are two regressors, three unknown parameters, beta naught, beta 1, and beta 2. Yeah. So there are three unknown parameters you can see, beta naught, beta 1, and beta 2 here. And this is the set of data which is given, the data set which is given, where two regressors are x1 and x2, and y is the response variable. And the data, uh, 1, 2, 3, 4, 5, 6, 7. Total 7 samples are being given. Question is, the first three questions are related. As you know that in the multiple linear regression analysis, we solve it using matrix method. So if you just calculate the beta, the matrix beta, which is in this case will be a 3 cross 1 matrix consisting of beta naught hat, beta 1 hat, and beta 2 hat, which I will discuss. So the first three questions are related because it asks about beta naught, next beta 1 and beta 2. Okay, so we will try to see how to proceed with this question. So let me do this. So let me write down the question again. So this is the first question. Actually, it is question 1 to question 3, I would say. Okay. It says to fit the model of beta naught plus beta 1 x1 plus beta 2 x2 plus etc. So from this, there are set of data which is given x1, x2, and y. Let me write quickly. This is minus 5, 5, 11, minus 4, 4, 11, then minus 1, 1, 8, then 2, minus 3, 2, okay, then 2, and then 3, this, let me write, this is minus 2, minus 2, minus 3, and this is 5, 5, and 4. Okay. So there are total n is equal to 7. So total number of samples is 7. So, and how many regressors? 1 and 2, x1 and x2. These are two regressors which are present. Therefore, k minus 1 is actually the total number of regressors, which is 2. Okay, this is the total number of regressors. Right? Therefore, the number of unknown parameters, which is k, is nothing but 2 plus 1, which is 3. Okay, unknown parameters. Now, unknown parameters of what? Unknown parameters in a fitted model. Okay, this is in the fitted model. So what is the fitted model now? So this fitted model will be nothing but beta naught hat plus beta 1 at x1 and plus beta 2 at x2. This is y. So this is the fitted model, okay, where epsilon is not present, you know. Okay, these are the estimators of the intercept and different slopes related to the regressor variable x1 and x2. Fine. So how to proceed the multiple linear regression problems? we generally write these x and y in some kind of a matrix form, where we generally do it in this way. So it is like x times beta, generally, right? Yeah, so it's beta hat generally we do. So how beta hat is calculated? Let me write that. Just writing the expressions because I have discussed in the last class. Okay. So beta hat is x transpose x inverse x transpose y. This is your beta hat. Okay. So what essentially you need is x and y, and which are given. So we can just proceed with that. So how will I write the x? Let us write x. So x is written in this way. So I'm just writing what I will write. The first column will be all ones, and then x1 and x2 are written. Okay, because based on this. Okay, beta naught into 1, beta 1 cap into x1 and then x2. So based on that, it is written. So 1 minus 5, 5, 1 minus 4, 4. Okay. Next is again 1. 1 is common in the first column. Minus 1, 1, 1, 2, minus 3, 1, 2, minus 2, and then 1, 3, minus 2, and finally it is 1, 3, minus 3. Okay. I got this, and this is what your X matrix looks like. So of course it will be a this is a yeah 7 rows matrix and a 3 column. 3 column representing for the this thing, the regressor x1, x2, and it is 1. Okay, so based on this it is written. So X matrix is 7 cross 3 matrix. What else we require is X prime. X prime is the X transpose. So transpose of X we can easily write. It will be a 3 cross 7 matrix or a 3 by 7 matrix. So it's just transpose we have to do. So it is 1 minus 5 5, 1 minus 4 4, then 1 minus 1 1, 1 2 minus 3, 1 2 minus 2, 1 3 minus 2, and 1 3 minus. This is your 3 cross 7 or 3 by 7 matrix, which is transpose of X. Okay, so this is transpose, X transpose. So this is the first thing which we have written down from the data set only. Okay, what else? It's okay. So I what I have to do is that we have to multiply this x prime times x, and its inverse has to be calculated, and then we have to do this. We can do it separately. X prime y. X prime is already there. Let me not write y right now. Let us calculate this part. Okay, x prime x inverse. You can always do it using your programming. Uh, you can calculate the inverses, which I have also done to check. So or otherwise you have to calculate using adjoint and all those things the way usually the inverses are calculated. Okay, so let me just do it quickly. Okay, so x prime x, let us first write x prime x. So how will we do that? I will again write this. So 1 minus 5 5, 1 minus 4 4, 1 minus 1 1, 1 2 minus 3, 1 2 minus 2, uh, yeah, 1 3 minus 2 and 1 3 minus 2. Right, this is your x, right? And this is your x. So it will be same 1 minus 5 5, 1 minus 4 4, 1 minus 1 1, 1 2 minus 3, 1 2 minus 2, 1 3 minus 2, and 1 3 minus. Yeah. So this is 7 cross 3, this is 3 cross 7. Fine. So finally, you know that it will be a 3 by 3 matrix, right? Because as the multiplication, matrix multiplication looks like. So I'll just write quickly the expression of x prime x. So x prime x is, so you can see that if you just multiply this with this, it will be nothing but the addition of all. So it will be 7 because there are total 7 ones which are present. The next will be 0, again 0. This will be 0. This is 68. This is minus 67. You can do it. And this is 0, minus 67. And this is 68. Okay. This is your explain x. Just matrix multiplication you can do. And in fact, when you will do this row with this, it will be just a square of this. So you will see that it will ultimately come to 68 and minus 67. These are the two values. And kind of a symmetric matrix. Uh, so now what we have to calculate is its inverse. For calculating inverse, we generally do a first calculated determinant, going the simplistic step by step. Okay, so it will be 7 into 68 square minus minus 67 whole square is 67 square. Right. So this will come out to be I think 945. You check the calculations, and you can write the adjoints. So I've calculated and finally written using the adjoints and determinants. I think this will be something 135 0 0 0 0 here also 476 469 469 and 470. This is how it will come. And finally, when you divide all these things, this is adjoint. Okay, adjoint of x prime x inverse, and this is the determinant of x prime x. Not inverse. Okay, this is x prime. So finally, x prime x inverse will come out to be. I'm just writing. Okay, so it is 0.14285714. This is 0 0. This is also 0 0. The symmetric matrix ultimately. So this second 2 element is 0.5037037. Okay, and this will be, oh, let me just, so this is x prime x inverse. Okay. So x prime x inverse is 0.14285714. This is 0, this is 0, this is also 0, and it will be 0.503737. This is 0.496296. Okay, this will be this 0.4962963, and this is 0.50370. Okay, so finally, this is our uh, inverse matrix. You can check with your calculations also. Okay, so finally, this is your inverse. Okay, now next is what else required is this x prime times y. Okay, so x prime I have already calculated. Only thing is y. So I just write it in this particular step. Okay, so x prime, let me just again rewrite minus 5, 5, 1 minus 4, 4. So that the steps are clear. Okay, I'm writing. So this is 1, 2, minus 3, 1, 2, minus 2, 1, 3, minus 2, and 1, 3, minus 9. Right? And y is 7 rows, 1 column matrix. So it will be 11, 11, 8, 2, 5, 5, 4. Right? So this is 7 by 1. And this is 3 by 7. So it will be ultimately a 3 by 1 matrix, which will be, I'm writing 46 minus 66 and 69. This is your x prime 1. Right? So all things for calculating the beta hat matrix has been calculated. One is x prime y, which has to be post multiplied to this inverse, x prime x inverse. Okay. So finally, beta hat will be x prime your x inverse post multiplication with x prime y. Once you do it, you will get, okay, let me again write one step so that it will be absolutely fine. So it will be 0.1428571400. This is 0.503737. This is 0.4962962. This is also 0.4962962. And this is also 0.503737. Okay. So these are also. And with this, you have 46 minus 66 and 50. Right? Finally, if you calculate, your beta hat will come out to be about 6.5714. This will be 1, this will be 2. Okay. So this is beta naught hat, this is beta 1 hat, and this is beta 2. One thing I did notice, which I have already discussed in the last class also when I was calculating one of the problems, showing one of the problems where this terms in the inverse, you take it up to large number of decimal places because it is extremely sensitive. These values, the number of decimal places. If you reduce the number of decimal places, you will get somewhat deviation from this particular answer. So when you are calculating, also using calculator, take as much as decimal places as you can, and then multiply with do the matrix multiplication. Otherwise, it will be not equal to this. Okay, so just for calculation purpose, if you don't get programming computers or something, then uh, use the calculators and take as much as decimal values as you can so that you reach the actual answer. Okay, so beta hat comes out to be this. So the first three questions in the assignment asks about calculation of beta naught hat, beta 1 hat, and beta 2 hat. And they are respectively what I have found out. So it is 6.57, this is about 1, and this is about 2. And one of the options in the first question is that 46 by 790. So this is nearly there, 6.57. So let me just quickly go to the questions again. Yeah. So what is the estimate of beta naught? It is 46 by 7. That is close to 6.57. Okay. Don't give 6. Next is that consider what is the estimate of beta 1? So estimate of beta 1 is beta 1 hat, which we have found out to be 1. And accepted answer is also 1. Consider the multiple distribution same way. Estimate of beta 2. So beta 2 hat, which we have found out to be 2. Okay. Up to this, it is all done based on the calculations. Next is somewhat different. We have to calculate the value of SST, the total sum of square. Okay. So the question 4 talks about the SST. Okay, the total sum of square. Its definition does not change much. The total sum of squares. Let me write. Okay, so how will we calculate this? The total sum of squares. We generally do it in this way. SST is equal to summation I is equal to 1 to n yi minus y bar whole square. So we know what are yi. So it is given in the question. So it is 11, 11, 8, 2, 5, 5, and 4. Right? So what is y bar? So you add all of them and calculate what is y bar divided by 7 because a is equal to 7 here. Right? So y bar will come out to be 6.57. Okay. So y bar is 6.57. Now you have to do what is yi minus y bar. If you do, so it comes out to be 4.43. I'm just writing. Each and every element has to be subtracted from this. This is also same. This is 1.43 minus 4.57 minus 1.57 minus 1.57 and minus 2.57. Okay. And we have to square this. So I have not check the squares, you can do it. Okay. So the squares of these quantities has to be calculated here, and then you have to add on. Okay, summation yi minus y bar whole square. Okay, so it will come out to be, this addition will come out to be about 73.71. Okay, so this should be your SST. Just let me check whether this is there or not. Yeah, 73.71. So, okay, so this is the SST. So the squares I have not calculated. You please check. Okay. Next is the SS regression. So for SS regression and SS residual, you have one expression, right? So we can calculate. So what is that expression? So question 5 asks about SS regression. So SS regression is a multiple linear regression, can be calculated using this beta dash x prime y minus n y bar square. Everything is there, right? This x bar y is there, beta hat dash we have calculated, and n is known, which is 7, and y bar square is also known, which is 6.57. Right? Oh, not y bar square, y bar is known, so it is this. So let me just quickly do it. So beta hat dash or prime x prime y. So beta hat primed. Okay, we were writing beta hat prime, not prime, beta hat as a 3 by 1 matrix. Correct. So beta hat prime will be a 1 by 3 matrix. So one row. So just take the transpose 1 and 2. This is beta hat prime. What about x prime y? We have already calculated. This is 46 minus 66 and 69. Right? So when you finally do the matrix multiplication, you will see that it comes out to be 374.2. Okay. So let me go to the question again, and you will find that SS regression is 374.29. I just know it's actually 72. Just a minute. Which is, oh, okay. Sorry. This is what? This is only this part. I'm sorry. This has to be also, this is also there, right? Ny bar square. So this is only this beta hat x prime x prime y. Okay. So SS regression is 374.22 minus 7 times 6.57 whole square. Okay. Once you do that, you will find this to be about 72.06. Okay. See, this kind of mistake can happen with beta hat prime x prime y. You are calculating and you leave that as an answer. And actually, it is present also. Close to that answer is also present, 374.29. So it is very cleverly made. So just careful while doing the thing. Don't make mistakes. What I have done. Okay. So ultimately the result you have seen that is 72. Don't forget to subtract n y bar square. Okay. Next is the question 6, which asks about SS residual. Okay. So let's see. Question 6 is about SS residual. So SS residual, how you will calculate? One way is that you do yi minus y hat and this square. This is also SS residual. Or we have an expression for the SS residual, which we have seen in the last class, which is y prime y, okay, minus beta hat prime x prime and y. This is already been calculated. What we need to find is this y prime y. Okay, what is actually y prime y? Y prime y is nothing but summation yi square. That's all, right? Because ultimately, if you see, it's a this y is a 7 by 1 matrix. Y prime will be what is a 1 by 7 matrix. So I'm sorry, this is no sorry, this is this. Correct? This is 1 by 7 and this y is 7 by 1 because y prime y. Okay. So this will be y prime y will be 1 cross 1 matrix. So it's just the summation of each and every terms in the y. right? So if I just go to this one, this is your yi, right? So can I calculate here yi square? Just quickly do it. 11 square is 121. This is 121 again. This is 64. This is 4. This is 25. This is 25. And this is 60. Add all those, you will get the answer to be 376. This, which is y prime y, is 376. So SS residual, therefore, is 376 minus how much is this one? It is 374.2. So the result will come out to be about 1.78 or so. Let's check. Yeah, it's 1.71. We're close to that. Okay, just check the answer close to that. Okay, so yeah, that's all. Next is the second question, which asks about consider the multiple linear regression model and data in problem one. What is the degree of freedom of SS residual? Okay, this is known thing that so question 7, which asks for degrees of freedom of that SS residual. We know that degrees of freedom of SS residual is nothing but n minus p, where k is the number of unknown parameters in the model. Okay, unknown parameters in the model, and this n is the total. We have seen it in the simple linear regression also. It was n minus the unknown parameters. So there are two unknown parameters there, beta naught and beta 1, in which case in the simple linear regression model. Okay, so there it was in minus 2 because there are two unknown parameters. But here it was there is three unknown parameters, right? So k is 3 here. Unknown parameters are 3. What are those? Beta naught, beta 1, and beta 2. You can write that also. Fine. Okay, and total number of samples is n, which is 7. So the degrees of freedom of SS residual will be 7 minus 3, which comes out to be 4. Okay, so this SS residual will have 4 degrees of freedom. Okay, so let's check. Yes, accepted answer is 4. And finally, one this testing kind of thing is given. So consider the multiple linear regression model. Is the overall regression significant or not? So for that, for the overall regression, we generally use the F statistic. Okay. So question A, which is based on some hypothesis testing, the overall regression. So here it will be this your H naught will be this all the things, right? So beta naught, beta 1, and so on to beta k minus 1, all are 0, and H1 is any of the betas is not equal to 0. Okay, at least one is not equal to 0, not uh, equal to, right? So at least one regression is not significant or significantly not equal to 0. Okay, they have asked to have a significance level of 0.055%. So we will use this. For F statistic, we have discussed so many times that it is nothing but MS regression, mean square regression divided by MS residual. Okay, so we will calculate each and everything. Okay, so MS regression is SS regression divided by K minus 1, right? Because the degrees of freedom of SS regression is K minus 1. The reason behind this is what? Because we know that SST is nothing but SS regression plus SS residue, right? So, and degrees of freedom you can add, right? So, for the SSP, the definition does not change. So, yi minus y bar whole square. This definition does not change. For this, there is one constant, correct? I is equal to 1 to n. There is one constant here. So, what is that constant? The constant is that summation, constant is that, I'm writing here, I've discussed also this. This is equal to 0. So, this being one constant, its regression, this degrees of freedom is n minus 1. For residual, we have seen it is n minus k. So if you now subtract or whatever way, it will be k minus 1. So if you add them, it will be n minus 1. Okay. Therefore, for regression, MS regression is SS regression divided by k minus 1. Okay. And what about MS residual? Is SS residual divided by n minus k. Right. So we have calculated SS regression, and what is that? About 72.06. Okay, let us write 72.06 divided by k minus 1 is how much? 2. 3 minus 1, which is 2. Comes out to be 36.03. Here, this is residual. I am taking what value I have got, 1.78. You can take 1.71 also, divided by 4, because 7 minus 3 is 4. This comes out to be 0.448. Finally, if you divide, which comes out to be the F statistic, MS regression divided by MS residual, that comes out to be 36.03 divided by 0.448. That comes out to be 80.42, which is a very high value, no doubt. But what to check for? This has degrees of freedom 2, this has degrees of freedom 4. Therefore, we have to check with F alpha 2 comma 4. Okay. Numerator and denominator. Numerator has degrees of freedom 2. Denominator has degrees of freedom 4. Okay. So F alpha is 0.05 as given in the question, 2 comma 4. This comes out to be about 6.94. Okay. So based on this, clearly F is greater than F of 0.05 comma 2 comma 4. So I can reject. Okay. I can reject H0 or accept H0. So it is significant. So overall regression is, so overall regression is significant. Significant only when we accept the H1, right? Overall regression is significant. Fine. So you come here. Okay. Overall regression is significant. Means if at least one of the regressor is significantly contributing to the regression model, we call that okay. The overall regression is significant. Fine. So these are 8 questions of week 3 assignment. So we have discussed all. Okay. So these are fine. Okay. After this, uh, we will just discuss one of the concepts of the last class, because that concept is required actually for understanding the week 5 lectures, which are already being uploaded in the uh, NPTL lectures. So for that, it is important, number one. And number two is that there is one question in the assignment 4, the week 4 assignment, which will be easier if you understand this. We will solve one question related to that, not exactly the similar question. Okay. So we will see that. But before that, let's discuss one one of the concepts of multiple linear regression. This is still not, we have not come to the selecting the best regressor model, that is a week 4 concept. Okay. This is also related to week 3, which I am now, I will be talking about. So this is extra sum of squares. This is also, I would say, related to a partial testing method. Okay. So this is extra sum of squares method. I have discussed in the last class one of the techniques of the partial hypothesis testing or partial regression testing or marginal test. where we have used what you call your t statistic to prove or the hypothesis, okay, to test the hypothesis particularly. This is another method to test the hypothesis. This is the base. We will use this concept in one of the questions later today. Okay. So what is what does it tell? So it is suppose we have a multiple linear regression model, okay, which is y is equal to x beta plus epsilon. Okay, then beta is having uh, k cross 1 vectors. Of course, because if you have suppose k minus 1 regressors, which we assume generally, okay, if you have k minus 1 regressors, then you will have one extra parameter than k. So unknown parameters will be k, uh, number of unknown parameters will be k. So that's why it is k cross 1. Okay, so this is fine. Now, our aim is here. Our aim is that we would like to determine if some subset of, so suppose R, which is less than this k minus 1, that is regressor, okay, contributes significantly to the regression model, to the regression model. Okay, so you have k minus 1 regressors. Okay, it might be possible that there are some R regressors out of this k minus 1 which are significantly contributing to the regression model. Others are not. So to test that, whether that R among which are regressors, whether they are significantly contributing to the regression model or not, we are testing one kind of a hypothesis. For that, this extra sum of square technique is used. Okay. So I'm just writing here beta is, now I'm writing in a different way. Let's say that beta 1 is having k minus r regressors, okay, and say cross r, and this beta 2 is r cross 1. This is x1. Okay, so beta 2 r cross 1. This beta 2 is not one quantity. Okay, these are r quantities. Remember, these are R regressors. These are corresponding to the R regressors. The unknown parameters corresponding to R regressors. Okay. So what I'm trying to say is that suppose this is y, beta naught plus beta 1 x1 plus beta 2 x2 and so on. And suppose this is beta 11 x11 plus beta 12 x12 and so on. Okay. Plus beta k minus 1 and finally, yeah, k minus 1, it's k minus 1. That's epsilon. So I am taking any, okay, any R of this subset and trying to prove that whether these are significantly contributing to the to the regression model or not. That's the thing. Okay. So these all these coefficients which I have taken, beta 1 1, beta 1 2, so on up to some beta 21 suppose. Okay, this art is this is written here in the beta 2. Okay, so beta 2 which I have written here, this one, this beta 2 consists of now beta 1 1, beta 1 2. This is one of the example I am giving. Suppose beta 2 1 up to beta 2. Okay, and this beta 1 that except the beta 2, whatever remaining, those those betas will come in beta 1. Okay, so this is what we try to talk here. Okay, here what I have shown there is that at last are unknown parameters, last are regressors, I would say. So last are regressors, whether they are significant or not. That is what we test. Okay. So your null hypothesis here becomes y is equal to x1 beta 1 plus epsilon. So these are related to the first k minus r elements. Okay. And h1 is y is equal to x2 beta 2 plus epsilon. This is your null hypothesis. That yes, the last r elements are significantly contributing to the model. And that's why we are accepting h1. That is what we wanted to see. Okay. So, or in other words, we can also write this as something this. So h naught, same thing. Beta 2 is equal to 0. H1 beta 2 is not equal to 0. If this H1 is true by our analysis, if H1 is true or accepted, then these are regressors are contributing if true. If H1 is true, then our regressors are contributing significantly. Okay, fine. So this is what it is. And for here, for this, we write a test statistic as f using f statistic only we do. So it is actually written as just briefly writing. This is SS regression of the full model, okay, which consists of k minus one regressors, full model minus SS regression for the restricted model. Restricted means there are R regressors, right? And divided by okay. This divided always you have to divide by the degrees of freedom because there are R regressors, R degrees of freedom will be there. And finally, this is residual of full model divided by n minus, which is we know this. This is nothing but ns residual of the full model. Okay. So this is the F statistic which we generally create to test this kind of a hypothesis. Okay. Now, if F is greater than F alpha R comma n minus k, then we accept H1 and say that the R regressors are significantly contributing to the model. To the model. Okay. So this is what we try to see. Okay. Here I have given one example, but what actually has been taken is that the last star regressors, suppose the last star regressors are significant. This is how we can tell. So one example also I have given here, you can understand from it. Okay, so this is how one this extra sum of squares method works. Okay, I will come to it with one question, not exactly related to the extra sum of squares, but to understand how to calculate one regressor in the presence of other regressor. Okay, so generally you will find that f of say x1, one regressor x1 in the presence of x3. How we will test? Okay, for this kind of a formulation is useful. So we will come to it later. Okay, so now let me quickly move to the week 4 concepts. Okay, and then we will solve questions today. Okay. So to week 4, brief contents, I will just write it down. Week 4 contents. So week 4 is particularly based on selecting selecting best regression model. Okay, selecting best regression model. So you have y is equal to beta naught plus beta 1 x1 plus beta 2 x2 and so on up to beta k minus 1 x k minus, which represents there are k unknown parameters, beta naught, beta 1 up to beta k minus 1, and there are k minus 1 regressors. Fine. So the thing is that it might be possible, so I'm just writing here, it might be possible that some regressors, okay, some regressors, which are some x's, okay, might not be that important, okay, might not be that important for explaining why. Okay. Now, question is that which x's, which x or regressor to be removed and which regressors to be kept, so that we can uh, fit, so that we can fit a regressor model, or we call that as a best regressor model. Okay, all parameters or all the regressors might not be that important in order to explain the why. So, which all regressors we should keep, which all regressors which we will not keep, that is, so this selecting the best regression model based on certain criteria, we try to find out that which regressor models is best explaining the why. Not all parameters are important. That is what the key point here. Okay. So for an example, I can give that, suppose that agricultural yield thing. Okay. So suppose this Y is the agricultural yield, the crop production at a particular area. You have T maximum, T minima. Okay. These are all important parameters, right? The next is sunshine hours. Okay. These are all regressors. X1, X2, X3, relative humidity, X4. Okay. Then, well, rainfall. Okay, rainfall is also another parameter x5. So based on this, you can find out the why. Okay, but I am also including some parameters like, let's say, temperature at 500, or a temperature at a height of 5 kilometers. Okay, this is suppose x6. Maybe T at 5 kilometers is changing some very small contribution towards the y. So we don't need this, correct? The temperature, air temperature at 5 kilometers might not be that important for y. Okay, the crop productivity might be important. We don't know. So we can remove this and take these are the important parameters in the model and fit the model. So to reject or remove certain parameters, we use this best regression model. Selecting the best regression model is actually for that. Okay, fine. Let us see that what are the possible combinations we can make. So this is also discussed in uh, lectures in the NPTEL. Okay, let us see all possible combinations for the regression model which I have shown above. Okay, possible combination. I will give an example also once I write this. Okay, so suppose this is number of regression. Okay, number of regression. Well, this is, you can say that, possible view. Okay. So if there are no regressions, suppose zero, then what will be your y? It will be nothing but beta naught plus epsilon, right? Because number of regressions is what? K minus 1. So if k minus 1 is 0, k is equal to 1, one unknown parameter will be there, and what is that? Beta naught, because no regressions are there. Okay? For that, it will be k minus 1 is 0, which is nothing but 1. For one regression, you have two parameters, which we know that simple linear regression model. For that, it will be k minus 1 C1. So there are k minus 1 ways you can write the possible combinations you can write. I will give you example, don't worry. Okay, next for 2, it will be k minus 1 C2, whatever it is. Check the value. Finally, k minus 1 regressors. For that, it will be k minus 1 C k minus 1. It is also 1. Therefore, the total number of possible ways is written as 2 to the power k minus 1. Okay. So, so all these, if you add, it comes out to be 2 to the power k minus 1. So let me give you one example. Say, suppose suppose we have two regressors. Okay. Suppose we have two regressors. Therefore, k minus 1 is nothing but 2 because there are two regressors. So what will be k? It is 2 plus 1, which is k. Also, for two regressors, what is the model? Beta naught plus beta 1 x1 plus beta 2 x2. And how many ways we can write based on this? It is 2 to the power k minus 1, which is nothing but 2 square, which is 4. So there are four ways we can write this model by removing one parameter or adding one parameter. So let us see. So for no regressors, C0 is nothing but y is equal to beta naught plus epsilon. Right? This is one of the ways. Next is 2C1, which is having one regressor. This is having zero regressor. Okay, this is having one regressor. What we can write here? So this has to be in two ways, right? So this can be written as, well, one regressor will be there, so it can be either beta naught plus beta 1 x1 x plus epsilon, or y is equal to beta naught plus beta 2 x2 plus epsilon. These are the two ways you can write. Is there any other way? No. Because there has to be one regressor. You cannot have all. Next, 2C2 or two regressors. This can be written as one way, which is the actual model. Beta naught plus beta 1 x1 plus beta 2 x2 plus, right? So total number of ways is how much? 4, which is nothing but 2 square. We have seen. Okay. So this is one of the example. You can take three regressor variables. Then what will be the uh, total number of possible ways? 2 cubes, 8 ways. Huh? And in the lecture, Week 4 lecture, you will find that sir has taken, I think, four regressive variables and showed all 16 possible combinations in equations and its different parameters through which we generally understand that what is which variables to keep or which regressors to keep and which regressors we will reject. Okay, so this is one of the point, and then some criteria, not all, but some criteria are being discussed here. Okay, number one is that, so these are the criteria for selection of best regressor model. Okay. Number one is RP square. What is this RP square? It is coefficient of, in simple linear regression, we have seen that coefficient of determination is one of the important things. Here we define it as coefficient of multiple determination. Okay. This is coefficient of multiple determination. P, okay, this P is number of unknown parameters. Remember, this is number of unknown parameters, not the number of regressors. So what will be the number of regressors therefore? It will be P minus 1. Okay, simple. Fine. So how it is defined? This RP square is defined as, either you define it like this, is this regression of P unknown parameters divided by SS total, or it can be 1 minus SS residual of P divided by SS total. Simple definition which we have used in the simple linear regression also. Same is being used in the multiple linear regressions. Okay. This is number one. So just look into it here. If P is equal to 1, that means one unknown parameter. Okay. What another thing we can say here, that P minus 1 is 0. That is number of regressors is 0. Okay. When number of regressors is 0, then your SS regression will be 0, right? So SS regression will be 0. Therefore, your SS, according to the equation, SST is SS regression plus SS residual. If SS regression is 0, therefore SST is equal to SS residual. Remember, only for P is equal to 1. So SST is equal to SS residual for P is equal to 1. Okay. Now we will use this. We will use this when we start solving the question. This is an important thing. So if you have given some data set, you don't need to calculate the y's, okay, to calculate the SSP. Just look at it, which for p is equal to 1, just look at it, what is the SS residual. If you are giving the SS residual, just calculate SSP. That is the SSP. Okay, fine. This is number one. So how we can, the preference condition is what? So we will prefer here in RP square, we will prefer, we will prefer that model where R2 square is actually maximum. Out of all these possibilities, so what is being done is that out of all these possibilities, you calculate RP square and see, check which RP square is maximum. That model is the best model according to this RP square criteria. Okay. Second is residual mean square. Okay, residual, nothing but M is residual. Okay, so simple. We know the definition of M is residual for unknown parameters P is nothing but this is residual for unknown parameters P divided by N minus P. Just what we are writing as N minus K and P is equal to K. So I'm writing here now P. Okay. K is now P. Here, lower value is good. Okay, so lower value indicates better fit. Why? Because it is the residual. Residual is nothing but the errors in the fit. Okay, so once the error is small, that is the best fit. Correct. So it indicates better fit. Correct. This is fine. Okay. Next, so minimum value. Here the minimum is the best. Third is your adjusted RP square. This is another quantity, adjusted RP square. We call this as RP square bar. Okay. So this is generally defined as RP square bar is 1 minus ms residual of P divided by SSP or MST, mean square total. So that is, so what is ms residual of P is as I have defined. So this is residual by of P divided by N minus P and ms total, which is SS sum of square, total sum of square divided by N minus 1. Just divided by the degrees of freedom. That's all. So this is adjusted RP square. This is another method. So maximum of RP square bar will be good. Why? Because look into the expression, okay? Adjusted RP square expression. See, I have told you that if MS residual is small, if this is small, that means the error is small. That means it's a good model. So if error is small here, means this quantity is small, 1 minus the MST is suppose fixed because ultimately SST is fixed, right? It depends on Y. So if this is fixed and this MS residual is low or minimum, then 1 minus this quantity will be high, right? And because of that, we are considering the maximum value of adjusted RP square or coefficient of multiple determination will be a good model. Okay. The fourth one is the mellow statistic. Fourth one is the mellow statistic. CP. There are other criteria which I am not talking because week 4 is particularly up to this. Okay. So this is the mallow statistic represented by CP. So its expression is SS residual of P divided by MS residual full model. Remember, this is MS residual of a full model and divided. So numerator is SS residual. That minus n plus 2 into the number of unknown parameters. This is how the PP is defined. Very important, the conditions are that you must have lower values of CP, and the second condition is that not only that you should have the lower values of CP, but CP, this value, should be comparable to P. So if CP is about 2.03 suppose and P is suppose 2, then we can say that yes, this CP is close to 2.03 because this value CP is comparable to 2 when two unknown parameters are there. Okay, we will see these questions. We will see. Okay, so these are the four criteria to understand which of the models or which of the regression variables to be taken or not to be taken in the regression model to have a best regression model instead of taking all the regression variables. Okay. So these are the four conditions. So that's all. Now we will go for the questions. These are the some practice questions which are there. We will solve them, and I will also show you that how the questions will look like in the assignments. So based on that only, we will see. Just excuse me for a moment. So I have two questions today, and let me write. Okay. So the first question, I'm not writing the entire question, just giving you the possible whatever required parameters. I will give the values of those, and we will see how we can understand that which one which one of the regressors to be taken or not to be taken in the to have a best regression model. Okay, let's say that in there are 13 samples. I am not giving the samples X and Y, all those things which are previously given in the previous questions. I am not giving now the X and Y. I will give some combinations. Okay, so n is equal to 13. There are 13 samples. So just for kind information, it is n is equal to 13. Okay. Now there are there are three regressors. Okay, there are three regressors. So what does that mean? K minus 1 is equal to 3. So what is K? Is 4. Therefore, 4 unknown parameters. Okay, done. This is fine. From whatever is given, we have taken this. So now this regressor, the question will be given like this: regressor in model and the SS residual. This will be given to you. Okay. So for zero regressor, the SS residual is 2715.76. For one of the possible regressors, say x1, if it is only x1 if it is present, then SS residual is 1265.68. If x2 is present, then it is 906.33. If x1, x2 is present, it is 57.90. If x3 only is present, then it is 1939.40. If x1, x3 are present, then it will be 1227.07. If x2, x3 are present, it is 450.44. And finally, when all the three regressors are present, that is 48.11. So you can understand that what is happening. So there are four your unknown parameters or three regressors which are x1, x2, and x3. So how many possible combinations? Eight possible combinations, right? 2 to the power 3, 8. And we are saying that there are eight possible combinations. 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is for k minus 1 equal to 0. No regressor. These are for one regressor. Three combination, right? Because 3C1, right? Next, 3C2 is your two regressor combinations. So 3C2 is also 3. And finally, your 3C3, which is 1, which is all regressors are present. So this is the uh, combinations, possible combinations. So 2 to the power 3, 8 possible combinations are given. Okay. And its corresponding acid residual are already been calculated for you. Okay, you don't need to calculate each and everything because it will be a huge time consuming. So it is given in the question. Now, so as I have told you that there are three regressors, so two cube, eight possible ways are there. So the first question based on this problem is that based on RT square, that is, this is not the adjusted. For the adjusted, there will be a bar. This is the coefficient of multiple determination. Okay, RP square. Which model, which model you prefer the most? Okay, which model you prefer the most? Okay, so for that, what I will do is that each and every model we have to see what is the RP square value and calculate. So what is the RP square, by the way? RP square is defined as, because SS residual is given, so I am writing this SS residual for P divided by SS total. Remember, what is SS total? How we will calculate from this data SS total? There is no Y which is given. So there you have to remember that SS3 is actually SS residual for P is equal to 1. Right? P is equal to 1 means what? P is equal to 1 means no regression. So when there is no regressor, then SS regression is 0. So SS total is nothing but SS residual. Right? So what is that? For P is equal to 1 is this. Okay, this is nothing but P minus 1. Okay, these are all P minus 1s. So this is 0 regression. So for SS residual P minus 1 will be this one. So SS total comes out to be therefore 2715.76. Directly you can write. This is SS total. Then one of the problem is solved, that SS total is found out. Now, for each of the regressor combination, we will find out RP square and comment on which will be the best. Okay. So let us do one by one. Okay, so let us say regression. Okay, and RP square. So for zero regression, RP square will be zero because SS residual is equal to SS total. Let us do one thing. This is R P square. Actually, P has to be 1 here. So it will be 1 minus SS residual by SS total. So this SS residual and SS total for P is equal to 1 is 1. So this is it. Okay. For X1, what it will be? So it will be, let me write here. Okay. R2 square, which will be 1 minus SS residual for this case is 1265. Make some space. Okay. Let me write here R2 square. Okay. And this is the calculation. Calculations you also can do, it's fine. So it will be just 1 minus 1, that is 0. So put it here 0. X1, this will be 1 minus 1265.168 divided by 2715.76. This is SS total and this is SS residual. This is SS residual for X is X1. And this comes out to be about 0.53. For X2, what is there? It will be 1 minus. For X2, let us see. This is 906.33. Let us write 906.33 divided by 2715.76. How much it will be? I have calculated, it comes out to 0.66. Fine. Let us calculate X3 first. Okay. Let us not jump to X1, X2. X3 is 1939.40. So it will be 1 minus 1939.4 divided by 2715.76. Okay. So this will come out to be, I have calculated, to be about 0.285. Okay. Just based on the definition which I am doing. Fine. Next is your X1, X2. Now we were looking at P is equal to 2 here. Okay. This is P is equal to 2 or P minus 1 is equal to 1. One regressor. Correct? This is P is equal to 1 and P minus 1 is equal to 0. No regressor. Because this is nothing but number of regressors. Okay? Just remember. Next is whatever we will do. Here P will be equal to 3 and P minus 1 will be equal to 2. Two regressors. Okay? So this will be 1 minus. Now x1, x2, SS residual. Let's see. This one 57.90. 57.90 divided by 2715.76. How will you do it? So if you calculate it, it will come out to be 0.978. Looks like a good one, right? Next, x1, x2. Let's do it. X1, x2. So for it, it will be, where is x1, x2? This is 1227.07. 122, what? 7.07 divided by 2715.7. So what it will be? Finally, calculated, it is 0.548. Yeah, 0.548. 548. Fine. Next is x2, x3, which I'm just now writing. It is 0.847. Okay. 1 minus, okay, 415.44 divided by 2715.76. And finally, for p is equal to 4, that is p minus 1 is equal to 3. Three regressors, all three regressors, which is 1 minus 48.11 divided by 2715.76. This gives you 0.9822. Okay. So based on this, if you have to reject. So there are some options which are given. Of course, this is higher. It will always be higher because x1, x2, x3, all variables are there. But this also will be a very good model because it's 0.978, close to this, but x1, x2 can explain almost the all the variability related to this 0.982, which is explained by the x1, x2, x3, the entire model. So I would prefer x1, x2 regression model to be the best model here. Because ultimately our aim is to reduce the number of regression, right? Regression. So of course this is high, but this is also quite strong, about 0.98, and one regressor is missing. So this regression model will be good. So it will be related to I think this y is equal to beta naught plus beta 1 x1 plus beta 2 plus x1. Right? One is lost, one regressor variable is lost. So that is quite good. Okay. So this is the goal because RP square condition is that you will have the best model when it is maximum. Although maximum is at x1, x2, x3, but it's better to remove one variable and see that this is also very high. Okay. So that is the that is one of the questions. Fine. Question two of this same question repeats. So one of the parts is that the value of CP mallostaticity. Okay, the value of the CP for x1 is 3. Okay, this is given that you the question asks that for x1 is 3. What is the value of the mallostaticity? Okay, so x1 x3 means what is the model? It is beta naught plus beta 1 x1 plus beta 3 x3 plus xn. Right? For this, what is SS residual which is given in the question? X1 x3, this one 1227.07. 1227.07. This is the SS residual. Okay, no problem. So what is your P here? 2, because two regressors are present. Sorry, P will be 3. Okay. P minus 1 will be 2. P is 3. Correct? So now, what we will write here is the M is residual. Oh, sorry. Let us write what is CP. Definition of CP. It is SS residual, which is of this case. Okay, I'm not writing the bracket P or A. Divided by M is residual. Remember, this is for the full model. This is for the full model. Very important. Minus n plus 2 times p. Okay. So now what we will do is that okay, this SS residual we already know. What about NS residual for the full model? So full model NS residual will be SS residual for the full model. Full model means what? X1, X2, X3 all are present divided by n minus the total p, that is whatever present. Okay. For this n minus p is also for the full model. Okay. So let us just calculate MS residual for the full model. So okay. SS residual for full model is given 48.11. So write it is 48.1. What about n minus p? N is 13. I have already told in the beginning of the question. N is 13 minus. What will be the value of p? See, if this is for the full model, which consists of x1, x2, and x3, which means there are three regressors. P minus 1 is 3. P will be what? 4. Therefore, it will be 13 minus 4. Okay. Don't confuse between this full model and this SS residual. This is different. Okay. Once we do it, comes out to be about 5.34. Okay. So MS residual for the full model is 5.34. Whatever this is residual for the this x1 x3 model is 1227.07. Let us put it. So C of 3, because we are calculating for this. Okay. C of 3 is 1227.07. That is, this is residual for uh, two parameter model, two regressors divided by n is residual for the full model minus 13 plus 2 into 3. Okay. This will give you 222.7, which is not a very good, because it should be close to 3, near 3. Okay. So this is not a very good model, which we have seen through RP square also. Okay. So this is how you calculate the mallow statistic. Fine. So this numerator SS residual is directly from whichever regression is being asked to calculate. That is x1. But M is residual for the entire. Just remember this. And the degrees of freedom while calculating M is residual will also be for the entire. Fine. Let's now. Okay. So these are the two problems for the first question. Now the next one is a relatively longer one. So let me write that question again. Okay, this will be for four regressor variables. Okay, this is one of the questions for four regressor variables. So here there are four regressors. So it will be x1, x2, x3, x4. Okay, so possible ways will be 2 to the power 4, which is 6. So let me write the regressors and its corresponding SS residual, which will be given in the question. Okay, so same way, regressor in model and your SS residue. So 0, or sometimes it can call as none. Okay. Then what is the SS residue for this is 12.208. Then x1, that is 12.031. Give me some time, I am writing this. Okay. X2 is 9.979. X3 is 7.332. X4 will be 7.409. Now comes x1, x2, which is 9.443. X1, x3, 5.781. Next, x1, x4, 7.299. X2, x3, 4.312. X2, x4, because these are all possible combinations, 6.622. X3, x4, 5.130. Now, three model. So x1, x2, x3, three regressive model. Okay. So that is 3.109. X1, x2, x4 is 6.570. X1, x3, x4 is another possible. So this is 4.968. X2, x3, x4, this is another possibility, which is 3.614. And finally, x1, x2, x3, x4. All four, which is 3.084. Okay. So these are the things. Okay. So this is 4C0, which is 1. These four are 4C1, which is 4. These are 4C2, which is 6. Okay. And finally, 4C3, which is 3, and 4C3 is 1. Right? So the SS residual all are given. Now, questions. Let us quickly do the questions. Few other questions. The first question is you have to calculate the male statistic. Okay. So let me now. So the first question is you calculate. So it's a good revision. Calculate CP for x2, x3. Okay. So what we need to find out SS residual for x2, x3. What is that? Let us find out x2, x3. 4.312. Okay. So this is 4.312. Okay. What is N? N, I forgot to mention here in this question, N is 54. There are 54 samples in the data, but that is not important here. So N is given to be 54. Fine. What about P? In this case, what is P? P is two regression variables, so 2 plus 1, so 3. Correct? Number of unknown parameters. P is number of unknown parameters. Okay. So what we need to calculate is that C3 for x2, x3. This is we need to find. But for that, we need what? MS residual for the full model. Full model means x1, x2, x3, x4. We require SS residual for same x1, x2, x3, x4 and divided by n minus p of the full model. So what is p of the full model? Is 4 plus 1, which is 5. Why? Because there are 4 regressor plus 1 is the number of unknown parameters. Okay, done. So SS residual of the entirety is 3.084. So let us calculate MS residual for the full model is 3.084 divided by n, which is 54, minus p full, which is 5. Comes out to be about, I think, 0.0629. Okay. So MS residual for the full model we have calculated. We have calculated SS residual for x2x. Now I think there is nothing. So we have to calculate C3 for x1, x2. Oh, not x1, x2, 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 x3. So how what it will be? Formula SS residual for x2, x3 divided by MS residual for the full model minus n plus 2 into p. Not for the full, okay? P is for this. So what it is? 4.312 we have seen divided by 0.0629 minus 54 plus 2 into 3. So this comes out to be about 20.55. Okay. So C of 3 or x2, x3 will be 20.55. This is the answer. Okay, fine. So as you can see that x2 and x2, x3, the model with x2, x3 will not be that good according to the Manor statistic because had it been the C3 close to 3, it will be a good model. Fine. This is the first. Second is again based on Manor statistics or CP I am writing. Which of the following would you prefer most? Okay. Which of the following you will prefer most? So I will give some cases. A is it x1, x2, x3 will you prefer, or x1, x2, x4, or x1, x3, x4, or x2, x3, x4? Out of these three, which one you will prefer the most? Okay. So we have to calculate the CP for each case. But before that, let us see what are the common information given for all the cases. Common info. One of the biggest common info is the MS residual for the full, which is SS residual, which we require, right? For each and every cases we require. The SS residual full divided by N minus E full. So full means what? Full means x1, x2, x3, x4. All regressors are present. So we have seen it, we have already calculated. So this is 3.084 divided by 54 minus 5, which is 0.0629. This is the common information which we get. Next, all of them, all the cases, there are three regressors. So there are three regressors in all cases. So p minus 1 is equal to 3. So p will be equal to 4. Clear? This is done. Okay. Now let us go one by one. Case 1. So case A. What is that? X1, X2, X3. Right? So what is the SS residual for this? The SS residual for X1, X2, X3 is, let's see, 3.109. Let us write 3.109. Okay. Now we have to calculate C, because malus statistic to malus statistic we have to do. So P is 4 in all the cases. C 4, case A. I'm writing like this. Okay. So this is 3.109 SS residual divided by the full MS residual. So 0.0629 minus 54 N plus 2 into 4, because there are 4 P. What I get is 3.42. So C4 of A is 3.42. A is the X1, X2, X3. Let's see case B, where x1, x2, x4 are present. What is the SS residual for that? I'm just writing it is 6.57. You can check it from where is it? Yeah, x1, x2, x4, right? Yeah. 6.57. So this is done. So C4 of B is 6.57 divided by 0.0629. This will not change because it's for the full model minus 54. This is also not going to change 2 into 4. That comes out to be 58.45. Okay, so C4B for the case B it is 58.45. Let's see case C and case D. So case C is x1, x3, x4. SS residual, I'm just writing it is 4.968. So C4 of C is 4.968 divided by 0.0629 minus 54 plus 8. Just I'm writing, okay, 2 into 4 is 8. So here it will be 32.9. So C4 of C. And finally, case D, the last part is X2, X3, X4. And corresponding to that, the SS residual given in the question is 3.614. So C4 of D is 3.614 divided by MS residual of the pool, that is calculated already, minus 54N plus 2 into 4, 8. So that comes out to be about 11.4 C4D. So out of these all three, which you must prefer, you should prefer is this one, correct? This one, 3.42 is the minimum, number one, and it is close to 4. Okay, so case A will be preferred as 0.42 is close to P is equal to 4 and it is the minimum. So model will be x1, x2, x3. That is preferred. Okay, so this is one of the questions which can come. Next, let's see which one to be taken. Okay, let's do. So this is the first question or the second question? The second question. Let's do for RP. Okay, so this is the third question. Let's do it quickly. So it is given that the model is this: beta naught plus beta 2 x2 plus beta 3 x3 plus epsilon. Okay, so it says that calculate RP square. Okay, what is P in this case? 1 unknown, 2 unknown, 3 unknown. So R3 square actually has to be calculated, but for x2 x3 because there are many possibilities in R3 square. So x2 x3 only we have to take. What is the definition of RP square? Is 1 minus SS residual of P divided by SSP. Again, we will calculate SSP as SS residual of 1. So this is nothing but SS residual of 1, which is given as in the question very clearly that when there is no regression in the model, that is P is equal to 1, it is SS residual is 12.208. And that is nothing but your SSP. So 12.208, right? Okay. This I have already shown how we are arriving at this one. Okay, now let's calculate R3 square of x2 x3. So it is 1 minus, let's quickly see what is the SS residual for that. X2 x3 4.312. So it is 4.312 divided by 12.208, which is 1 minus 0.3366, comes out to be 0.6633. So R3 square or RP square, whatever you want to say, for x2 x3 is 0.66 or 66.3%. In percentage, it is just multiplied by. Okay, this is the answer. Fourth question, again some comparison with this question. So it says that based on the value of RP square, which of the following models we will prefer? Again, earlier we have seen for CP, now we will see for following will you prefer. This is for the RP square condition. Will you prefer most? Okay, so what are the options? So here it is given in the regression model: beta naught plus beta 1 x1 plus beta 3 x3 plus epsilon. B is y is equal to beta naught plus beta 2 x2 plus beta 4 x4 plus epsilon. C is y is equal to beta naught plus beta 2 x2 plus beta 3 x3 plus epsilon. And last, y is equal to beta naught plus beta 3 x3 plus beta 4 x4 plus epsilon. Right? So essentially, it is nothing but x1, x3. This is nothing but x2, x4. This is nothing but x2, x3. And this is x3, x4. Okay. All, so common thing is that your SS total is nothing but 12.208, which we have already calculated. This will not change. This is nothing but SS residual for P is equal to 1, which is zero degree. Okay. This is clear. Okay, and these are all two regressor problems. So P minus 1 is equal to 2 because two regressors in all cases. So P will be 2 plus 1, which is 3. Done. Now each and every cases again case by case we will do. So case A, x1, x3. Okay. So what is SS residual? I'm writing. I have the values. This is 5.781. You can see the question also. Refer to the question later. Okay. So R3, because P is 3, square for case A is 1 minus SS residual for this case divided by this is 12.20, which is 0.548. Okay. This is one. Case B. Case B is that it is X2, X4. What is SS residual for that? I have the value, which is 6.6. You can check the question later, okay? So this is, I'm just writing R3 square. B, for the B case, is 1 minus 6.622 divided by 12.20, which will be 0.483, right? Next case C is X2, X3, which has SS residual 4.312. So R3 square for the part C is 1 minus 4.312 divided by 12.208. Okay. This comes out to be 0.663. We have calculated it. Okay. And last B is X3 X4, which has a residual 5.130. So your R3 square B is 1 minus 5.13 divided by 12.20. Okay, 0.59. So which one is better? 0.599 in D, 0.663, 0.483, 0.55. So this is okay. So case C, which is x2, x3, will be preferred because maximum of RP square has to be preferred. Okay, because RP square is maximum. Therefore, so y will be equal to beta naught plus beta 2 x2 plus beta 3 x3 plus x5. This is the first model. Okay, so this is how you have to proceed. Each and every cases you have to see. Finally, one question on, let me see whether I can do it or not. No, I think I cannot do because time is not there. Okay, just one question based on adjusted RP square. Okay, this adjusted. Okay, adjusted RP square. So how it is defined is that RP squared bar is yeah, it is 1 minus ms residual of P divided by ms T. Right? This is the definition. So let us calculate this for y is equal to beta naught plus beta 4x2 plus epsilon. Okay. So so you can see that it is for P minus 1 is equal to 1. So P will be equal to 2. 1 regressor. Right? So it is there. Okay. So what is SS residual for X4? Because that is the only regressor, right? So that is, let us see. Where is the question? The long one. X4, right? 7.409. Let's go down. So this is 7.409. So what is SST by the way? SST is fixed, so it is 12.208. We have calculated. Okay. Now, what we require? MS residual. So it is SS residual for X4 divided by N minus P. So it is 7.409. N is 54 minus 2. Right? So 7.409 divided by 52 comes out to be 0.1425. This is MS residual for export. What about MST? SST, that is 12.208 divided by n minus 1, because SST will be always n minus 1. So it is 0.2416. So finally, adjusted R2 square bar, which is nothing but R2 square bar, will be for X4 is 1 minus 0.1425 divided by 0.2416 will be 4.41. That is 41%. Okay, this is how the answer is. So let me give you one question. You can solve it on your own, like the way which I have done for the last couple of questions. So the question is that you can do it later, okay, or later practice. Okay. So based on the value of adjusted RP square bar adjusted, okay, which of the following models would you prefer? Most. Okay, let's do them. Understood. So the options are x1, x2, x3, B, x1, x2, x4, C is x1, x3, x4, and D is x2, x3, x4. So you have to calculate each and every cases and tell me that which one will be the most preferred model. Okay, you can do it later. You can come next Tuesday, uh, and in the starting maybe we can discuss whatever result you have got. Okay, so okay, now the important thing is that one of the questions I have seen in the week 4, which is based on the age statistic. So let me just quickly give that uh, how to calculate that. So suppose you have been given one question that calculate, that is, it is somewhat related to the extra sum of squares, and that is the last question which I will solve today. So calculate f1 oblique 3 value. It can be anything. Okay, it can be 1 oblique 2 comma 4, anything. Okay, you will understand this when you go to the week 5 lectures and try to understand that. But for solving week 4, I'm just solving one of the questions. Okay, so this is something related to the extra sum of squares. So if 1 by 3 or anything, 1 by 4, whatever, is given as SS regression of 1 means x1, okay, comma x4, not x4, sorry, x3, okay, because 3, this is 3, minus SS regression of x3, okay. So this is the thing divided by your SS, sorry, M's residual of x1, x3. So what does it mean is that 1 oblique 3 is that you calculate the F statistic for x1 in the presence of x3. F statistic for x1 in the presence of regressor variable x3. For that, what we do is that we calculate the full, that is SS regression of x1 comma x3, both are present, minus when only x3 is present, that is x1 is not present here. So that becomes the difference will give you the contribution of x1 divided by ns residual of the code x1 comma x3. This is how it has to be done. Okay, I think it is similar to what we have done for the that what you call as the extra sum of squares. which today we have discussed. Okay, so this is how it has to be done. And okay, its degrees of freedom will always be one because only one regressive variable difference is there. So that is one, and this is ms residual, which is calculated as it is. So we will solve this at 1 by 3 for the same question which I have given. Okay. Things which are required is that SS3 is given or we have found is 808, right? SS residual, let us calculate residual for x1, x3. Okay, because we have to reach to SS regression finally. So SS residual is 5.781 for this case, x1 comma x3. SS residual for x3 is 7.332. These are all given in the question. What is not given is SS regression. We need to find that. So SS regression for x1, x3, which is required for this, what it will be? It will be SS total minus SS residual. Remember the formula? Okay. SS total is known. And what is SS residual? That is also known, right? So in this way, we can calculate SS regression, which is, I think, 7.027. Okay. This is SS regression for x1. Similarly, SS regression for x3, I need to find out, which is nothing but SS total, which will remain constant, minus SS residual x3, which is 12.808 minus 7.332. That comes out to be 5.476. So we have also calculated SS regression of x3. So these two are done. MS residual is left for x1, x3. Let's calculate that also. So MS residual x1, x3 is SS residual x1, x3 divided by n minus p. Now what is the p here? 2 plus 1, 3. Correct? So it will be, because two regressors are there, so it will be p minus 1 is 2, so p is the 3. So SS residual is 5.781 divided by 54 minus 3. Comes out to be 0.113. Now just you have to put it, f1 oblique 3 will be 7.027 minus 5.476 divided by 0.113. Okay, this comes out to be 13.6. Okay, so this is how you have to solve. Just look into the extra sum of squares technique, and if possible, look at the week 5 lecture 1. By the time you have to solve the assignment, I think by tomorrow night you have time. So see and check. This will be helpful. The last one, okay, because that is not quite really covered in the week 4. It is somewhat related to week 3 and week 5. Okay, so I stop here. Try this question. This is good for your practice. Also, you have to solve the assignment, so it will be easier for you to do. Okay, so that's all then. Any questions from your side? So is this questions means clear? This kind of questions will come in the assignment if you look, or in the questions final examination. Okay, so you have to compare and all those things. So these notes I will share quickly. So we have done two questions for practice based on selection of the best regressor model and some basic criteria for that we have seen, and we have discussed the week 3 assignments. That's all. Okay. Yeah. Okay. Thank you. So I will stop sharing now. Thank you, everyone. Bye.